Folks, we're going to try something a little different to start off tonight. Some different types of experiments. Let's see, what do I got here? I got some Elmer's clear glue. I'm going to pour into this plate. There it goes. You can see it pouring in. Oh, I spilled a little on my shoe. That's going to suck. There we go. Let me move this over into the field of view here. So that's some Elmer's clear glue that I just poured into that plate. I hope. Let's see how yeah, that looks like it's in focus. All right, what's next? Next, I'm going to add a drop of food dye. Let's see what colors I got here. Oh, looks like I got a bunch of different, what's this? Green, yellow, and red. Let's go with red, huh? Put a drop of red in there. Let me get this lighting just a little bit better. There we go. Put my drop, oh, actually that's green. Yeah, we'll do a drop of green. There it goes. Right in there. It's like resting on the surface, kinda. Okay, next step, I'm gonna add a drop of detergent. Dawn dish detergent. This is how simple this is, man. This is all you gotta do. A little bit of food dye in green food dye in Elmer's clear glue, and put a little drop of detergent on a toothpick. I'm gonna put it right in the center of that green dye. And it goes. Let's watch what happens. Interesting. It's not working quite as well as I'd like in the... No, you're not late. We're just starting out there, Welpsy. It does look like a little bit like it became an eye. I can't see real well. I'm turning up the... Yeah, that looks kind of cool, man. Glycerin also works, huh? It's not working as well as I'd like. Let me try a drop of red, okay? So we'll do a drop of red right over here. Although that is an interesting pattern, I must admit. All right, Welpsy, here's your red. A little drop of red right there. Boom. Thank you there, Motorola. All right, let's put a drop of Dawn detergent right there in the middle of it. All right, see what kind of effect we get. Ooh, having trouble with the focus, ain't we? Look at that. Look at that gorgeousness. Come on, man. What the heck is going on? You can see some interesting patterns developing as the red dye is less viscous, and it's spreading into a more viscous fluid. And you may see some patterns develop. Here, let's try it with white glue. White glue works better. I know white glue is going to work. So give me a second here. Let me find a new plate. I'll let you watch this kind of develop here. It kind of spreads out and then stops. You can see the two different dyes there as they're spreading through. That's just Elmer's clear glue. We're going to try it with Elmer's white glue. And then I've got some honey. So this phenomena that you're seeing of patterns that are developing as a less viscous fluid spreads into a more viscous fluid, it's called, those are fingers that are developing. Yeah, let's try some white glue. Well, yeah, let's do honey first. I'll do honey first, okay? You put that over there so I don't mess everything up. Let's do some honey. See how that looks. Okay. Here's some honey. That's very viscous. All right. Let's get a little bit more. Okay. Now we'll try a drop of, I think green. I think we'll see green pretty well. Hello there, David. Put a drop of Technetium educational in terms of the element is the way I go. Let's do a drop of the green dye right there. And then we are going to, inside of that drop. So the drop doesn't spread out much because it has a high surface tension. Hello there, cold cat. And, you know, the honey has a high viscosity, so it's tough for the dye to spread into it. But if I add a drop of detergent, that's going to lower the surface tension of the dye. And look at that. So you can see like fingers growing out of the dye. Those are called viscous fingers. And this phenomena is often seen when you take a less viscous fluid and you force it into a more viscous fluid. So Toby Richardson, we are making viscous fingers. They make, art-like patterns, but it's really science that's going on. And right now, what it is, it's a little bit of green dye that I've added to honey, and then I added a drop of detergent. Here, you can watch it happen here. I'll do another one with some red dye. How you going there, Niley Bear? So those little, I don't want to say little, but those protrusions that you see growing, those are called viscous fingers. Viscous fingers. Here we go. Let's add a drop of detergent to the red dye. Hello there, Pearl. Boop, in it goes. And you can see the fingers develop quite quickly. Isn't that beautiful? It's just beautiful to me. Let's see if they penetrate each other. It does look like an iris. I agree. It really looks like an iris. Hello there, Doc. Doc Audit. Bella, what we're doing today, we're doing a repeat of a YouTube short I sent out, I think it was this past weekend, of creating viscous fingers. Thank you there, Toby. Yeah, y'all going to need to put your mature hats on. So, so that the terminology in this phenomena isn't, let's just say it's not for middle schoolers, okay? Welcome, Oliver. Welcome. Yeah, isn't that pretty? So you give me a second. Here, let me back it up so you can see both of them. I'll do one more droplet. Let's do one more droplet like in the center of the green and just see what happens. I have no idea what's going to happen if I do this. Let's do a drop of red. It does look like a little jellyfish. Hello there, Lock Aussie. Put it right there. Boop. And you can already see I added it to a spot that already had detergent, so that dye might start spreading out already. I don't have any on hand, Italy. Sorry about that. Do a drop of detergent, see what happens. And while that's spreading, I'm going to go get some Elmer's white glue. This will take me just a few seconds. Okay. All right, I'm back. Let me check out what's going on in the comments before we start trying this. That kind of made a mess, the red dye, didn't it? Hello, Zero. Hello, Random. Thank you there, BMO. Now drop the green inside the red. You got it? Muncho wants some green inside the red. Here we go. Doesn't look quite as pretty as the initial drop, in my opinion. Yeah, a little art and science together here tonight. Give it a little drop, see what happens. The Elmer's white glue is really cool. All right, let's try the Elmer's white glue. All right. So again, the phenomena we're observing tonight is the growth of fingers in a viscous fluid. Where did I learn how to do this? Well, I saw another creator online. Her name is Chemical Kim. She's here on YouTube. I think she's got a greater following on TikTok. But anyway, she showed the phenomena, and I thought, oh my gosh, that's the coolest thing. I got to try that. And so I did, and then I got into the chemical literature, and I started to try to figure out what was causing the phenomena that I was observing, and that's where I learned some of the terminology that they use to describe this particular effect of driving a less viscous fluid through a more viscous fluid, and it creates fingers. The less viscous fluid creates fingers as it penetrates the more viscous fluid. Okay, here we go. So this is Elmer's white glue. All right, Elmer's white glue. And I'm going to add, yep, Marcus, is all it is Elmer's white glue. That's right, Chauncey, I'm a teacher. And it is a hobby, both. Okay, here we go. I'm going to add a drop of green dye right there. Let's add another drop of green dye right here. All right, and I'll add a drop of red dye over here. I'm going to try to get the focus a little better. I'm not sure my camera's going to let me do it. All right, I'm going to add a drop of detergent to each. Now, right now, the dye is not spreading through the glue because the dye has a high surface tension. It's water, and so it's going to, the area is going to tend to be minimized. And also, the outer glue is very viscous, so it's very hard for the dye to penetrate into the more viscous fluid. But if I add a drop of detergent, that lowers the surface tension of the dye, and that forces it to spread out. And look at those beautiful patterns that are growing. Those are actually fractals. So I have measured the fractal dimension, the dimension of these, they call them viscous fingers. Look at that. Isn't that gorgeous? Come on, man. That's just beautiful. Those are actually fractals. Fractals are geometric patterns that do not have integer dimension. Like a square has 2 dimensions, a cube has 3 dimensions. A fractal has fractional dimension. Isn't that beautiful? It does look like snowflakes. I will not be eating it. It's very simple, too. Simple and beautiful. Like you can create art while doing some science at the same time. You got it, Gemini Eye. Here, let's add a drop. I'm going to add a drop of detergent to that green dye there to lower the surface tension. Whoop, there it goes. I kind of missed. So you can see that drop went off to the side, but you can still see the viscous fingers that are being created. Let me try to actually, no, let's just let it do what it's going to do. Who knows? Sometimes you just get some interesting effects. You can see over time it starts to bleed as well, but gosh, that's beautiful. It's just a beautiful pattern. It makes slime out. It does look like a Christmas tree. The branches of trees do, in some sense, form fractal-like patterns. I ask not, does this fall under Collette's conjecture? I apologize. I do not know what Collette's conjecture is. If you could give me a little more information about that, I might be able to comment a little better. I apologize. I have not heard of Collette's conjecture. Isn't that beautiful? Let's try to get another color in there, okay? Let's try another color. The green one does look like a tree. So let's try some neon colors here. I'm going to try a little bit of blue. Try a drop of blue here. Yeah, it does look like a root system. Here, let's do a drop of neon blue. Okay, here we go. I'm going to add a drop of Dawn detergent to the dye, the blue dye. Boop, in it goes. Fruity Pebbles, what I'm doing is I took some Elmer's glue, I added a drop of food dye, and then I added a drop of detergent to the food dye. Look at that gorgeousness. So the protrusions you see growing there, in the literature, they call these viscous fingers. They're called viscous fingers because they're finger-like projections, and it's occurring as a less viscous fluid, that is the dye, penetrates a more viscous fluid, which is the glue. It's beautiful. It does. Matt, I totally agree. It totally reminds me of the Mandelbrot set, especially at the beginning. It's all right, Angel Dust. Don't worry about it. I'm loving some science, baby. Come on now. Look at all that gorgeousness. So, yeah, this is, I did a video on this You know, I think it was this past weekend. I put out a video on this. Very nice. All right, let's try another one. You want to mix it? What am I going to mix it with? What do I have to mix it with? I don't have anything to mix it with. Hey, thank you there, Gemini. Gemini? Yeah, Khaled, you could make art from this. Unfortunately, as it dries, it bleeds, and those very sharp fingers tend to feather, and then they kind of tend to just, I don't know. Yeah, here we go. Yep, we're gonna bring out. You know, you got to bring your. All right, let's try. Like you can see all the mess on my stir bar here, stir plate. Let's try. Where's my plates? Here they are. All right, you want to do honey? Do you want to do white glue or clear glue? Let me know. Do a drop of yellow and red, half and half, then a drop of dish between the two. Gemini, you want to do honey? All right, we're gonna do some honey. Here we go. Oh, I'm seeing a lot of clear glue though. Yeah, clear glue's got you beat. Here we go. We'll do honey next. So here goes the Elmer's clear glue, and it goes. This is a little less viscous than the other two fluids. So viscosity, the way I think about it, is resistance to flow. And you can see when I poured that in there, that the fluid flowed pretty easily. All right. Now, what were the, let's see what they said. Somebody said do, oh, I missed it. How's it taste? Excuse me, I don't eat clear glue, so I wouldn't know. Here we go. I don't have any black, Khaled. All right, I'm going to do a drop of red, and I'm going to chase it as quickly as I can with a drop of detergent. Here we go. In goes the red. And in goes the detergent as quick as I can. Got it. And there goes the viscous fingers, heading out through the more viscous fluid. Yeah, I got some blue. We can do some blue. A little blue action. We'll do the blue maybe right here. Quickly chase it with a drop of, there we go. Oh man, look at that. That is gorgeous. Come on, baby. Come on, that's gorgeous. Holy cow. Look at how beautiful that is. It does. It looks like a supernova, man. Oh, that's beautiful. Look at that. Thank you there, Angel Dust. Yeah, we might have some kids watching. A lot of kids watch the channel. I don't make this videos for kids, but we do sometimes have them in the chat. Boy, that was pretty. Come on, that was, I'm so glad you guys told me to do. Look at that. Grim Reaper wants me to make both red and blue together to make purple. We can try it. We can try it. Here we go. Let's get to put green in between. Sure, let's do a green in between. So right there. All right. Let's look out at the big scale for a bit. Just to see what kind of pattern we got. Look at that. Looks like an alien. Oh, this looks like a hedgehog a little bit, this blue thing. And then up here, it's like two eyes and a nose. I don't know, some kind of red Darth Vader helmet or something like that. All right, let's do a drop of red, white, blue, baby. Come on. All right, let's do a drop of green right here. There we go. Chase it quickly with a drop of detergent, quick as I can, because it actually starts to sink. And you want the effect on the surface before it starts to sink. I think I might have missed it, though. Sonic and Knuckles. Sonic and Knuckles. That's hilarious. Pepsi logo. I'm loving it, man. Nice, Joey Scott. Yeah. Hello there, Quinn. All right, let's try honey. What do you say? Huh? Let's get this off here. Let's try honey. All right, let me get my next plate out. We'll do some honey. All right. Here we go. Hello there, Just Slytherin. Here we go. In goes the honey. So what we're doing is we're looking at a phenomena of making viscous fingers. This occurs when a less viscous fluid penetrates a more viscous fluid. Our more viscous fluid is going to be honey. Our less viscous fluid is going to be dye. And the dye is just water that's colored. Okay, so the way we do this is I put a drop of the dye in. The dye is water. It has a high surface tension, and so it won't spread out very much when I first add it. So we can't get the effect. But if I add a drop of detergent, that lowers the surface tension and allows the blue dye to spread out. Let's see what happens. There they are, baby. Look at that gorgeousness. Come on now. So those protrusions you see, they call them viscous fingers. And they make an enormous number of patterns. Thank you there, James. It is pretty, but I gotta admit, I think the prettiest thing I saw tonight was with the clear glue. Very pretty. Let's try another one off here to the side. We're sliding it around now. Okay, we'll do one over here. We'll do a red drop. See what happens. There's our drop of red. Give me my drop of detergent. Come on, real quick. See what happens. In it goes. Boy, I'm going to have a mess to look at that. Gemini, I will do that. Gemini says add a drop of alcohol. That's an interesting idea that I am going to try. I don't have any purple. I apologize. How does iodine react? I don't know. So you mean like a solution of iodine? I don't have any baking soda, but I do have some pink. So we'll try over here. We'll do it over here. I'm going to try pink, but I'm going to add a drop of alcohol. I have some isopropyl alcohol that I can add and see if it works. So we'll see if the isopropyl alcohol lowers the surface tension of the dye enough that we can get the, the viscous fingers to form. Joey, I cannot control what the pattern is. All right, so I got my isopropyl alcohol ready. I know you guys are like, there's no way he's got alcohol just because that guy said I do. Right here, see? 70% isopropyl alcohol. I'm going to add some of this. I got a bunch of stuff here in my lab in my basement. Okay, I got some drops of alcohol ready, and I'm going to add a drop of dye right here. We're going to chase it with a drop of alcohol and see what happens. Doesn't look like much, does it? I'm going to add some more alcohol just to see. I mean, something's happening, but it didn't look like much. So long there, Queen of NASA. There's like 4 drops. And while we're waiting for that, let's put like a couple drops right here. See if something weird happens. You can see the waves of the alcohol as it goes through the blue fluid here, but it doesn't seem to work as well as the detergent. Let me go ahead and drop. Well, there's something going on in there. There's a little bit of action. But it doesn't happen as I don't have any Windex. I apologize. Yeah, it doesn't seem to be happening as quickly as with the detergent. Let me put a drop of detergent in here. And off it goes. What prevents the colors from mixing? This is a good question. Look at that. You see how you get that sharp boundary between the colors? Here's what's going on there. So this is actually a surface effect. So what you're seeing actually happens on the surface of the honey. And as it spreads out, it hits a point where it's actually less dense. It's less dense than the surrounding fluid. Boy, actually, I don't know if it's not going to sink. Yeah, I'm a science teacher, Chinchilla. Yeah, it wouldn't be sinking. I don't know. I do not know why they don't mix in this particular case. I'm going to have to think about that. If you put a drop on top of each other, will it slide off? I apologize, I don't understand the question. All right, let's try some clear glue again, because in my opinion, that was the most beautiful. Although, I don't know, the white glue made some interesting fractal patterns, I thought. Very interesting fractal patterns. Okay. Spooky, what we are seeing is the following. I'm going to take some clear glue. Here we go. I'm going to back it off so you can see it. Back off the camera so we can see what's happening here. All right. In goes the clear glue into my plate. It's a fairly viscous fluid. And then I'm going to put a little bit of dye. I'm going to put a couple drops of dye in here. And then as quickly as I can. Okay, here we go. We're going to put a couple drops of dye in here. And then into each drop of dye, I'm going to put a drop of detergent. Now, the dye is almost all water. And water has a high surface tension. And so when it's placed in a viscous fluid, it won't spread out very much. So here we go. We're going to do this. I don't know. It's like a neon green or something. Here we go. Drop of dye. There we go. Let's add the drop of detergent. The detergent lowers the surface tension of the dye, and that allows the spreading out effect that you see. You'll notice they happen in finger-like projections. This often happens when a less viscous fluid, like the dye, penetrates a more viscous fluid. You get these finger-like projections. Look at that one that's kind of jetting out there. That's kind of interesting. All right, let's put another drop over here. And let's quickly chase it. Come on, with the dye. Hurry up before it spreads out. Boop, there it goes. There goes that one. And then we'll do a drop of blue. That's pretty. Look at that. It's like a firework almost. So yeah, this is these projections that you see here, they're called viscous fingers, and scientists and artists study this. It happens when a less viscous fluid penetrates a more viscous fluid. The difference in viscosity has to be about 10 times. Folks have studied this, so the viscosity of the dye is at least 10 times less viscous than the viscosity of the glue that I'm adding it to. In goes the detergent. And let's see what we get. It is beautiful, MV. Thank you there, Gemini. I agree, Gemini, but the problem with molasses, I imagine, would be that it's tough to see through. That is pretty. That is a pretty effect. Let's look at it from the... Look what's going on. And yes, we do have this non-mixing effect that goes on. And I apologize. I do not know why that occurs. I'm going to have to think about that. This one looks a little bit like a butterfly. More colors, says Pooh Berry Bear. You got it? Let's see. Let's do a, I don't know, let's do a green right here. I agree. I thought blue was just absolutely stunning. All right, there's my drop of green. Let's quick add a drop of detergent. And watch the magic. Doesn't look like much is happening. Akuma, not a good idea to mix those. I did a video about that. I mixed them together, but I did it in a hood, in a chemical hood. I agree, it would make cool t-shirts and socks. Wonder if peroxide would do anything. Gemini, you mean adding peroxide instead of the detergent? What the detergent does is it lowers the surface tension. Put 2 drops of different colors. I'm wondering. Yeah, that one's not spreading. That one's not spreading. I don't know why. Well, maybe it's starting. Maybe not. Green is broken. I'm wondering if sort of the detergent has kind of spread out over the whole surface. Oh, no, maybe it's starting there. Huh? Let's give it another drop. Let's kick it a little bit. I can tell the green has sunk down beneath the surface, and because this is mostly a surface effect, it's just really, I piled it in there like crazy. See if we get it going. If you don't catch the dye while it's resting on the surface of the glue before it sinks, you're not going to get the effect. And I wonder actually if that's what's happening here. So in these places where the dyes are not mixing, I wonder if at that point they are starting to sink and you're no longer getting the effect there. The pink is starting to look like lungs. About some orange. I don't have orange, but I'll tell you what I can do. Here's what we can do. We're going to do a drop of red and a drop of yellow. We'll do some white glue now. All right. Let me put that on there. We're going to do a drop of red and a drop of orange in some white glue. Where's my white glue? And we're going to see what happens. What if I swirl them with a toothpick? So long, Angel Dust. Thanks for your help. I appreciate it. Use a toothpick to pull it back to the surface. I like it, Denise. I might be trying that. All right. In goes the white glue. You can see this is much more viscous. It does not pour, nor does it flow as easily. So the white glue is the most viscous. What if you do the paint for the dye first and then the glue? That's interesting. I don't think it would work because I am pretty sure it's a surface effect. So if you put the dye down first and then put the glue on top, the dye would be on the bottom and not the surface. So I doubt that would work, but I apologize for not trying it. I would suggest that you try it and then drop me a line if I'm wrong about my... Okay, here we go. Akuma. What if I do it on a non-Newtonian fluid? I should try that with some oobleck, huh? All right, so what do I got? Do I got everything ready? I got my red and my yellow. We're going to make some orange. Hey, Chartreuse. Who you think's going to win, man? Chartreuse. Are we talking Mike Tyson, Jake Paul? Drop in the chat who you think's going to win. My opinion is if Mike lands an early punch in the early rounds, he's going to take it. But he's in trouble if the fight goes too long. That's my guess. Tell me about it, Chartreuse. I'm with you on that. Please, Mike Tyson. Hope he takes his face off. But here we go. We got a drop of red. We got a drop of yellow. Drop of detergent. Let's see what happens. Oh, it's beautiful. It's like a fiery red storm. This is what we hope we see from Mike tonight. We hope we see a fiery red storm, fiery orange red storm from Mike Tyson. Isn't that beautiful, y'all? Somebody said they wanted to see violet, so I think I can do a drop of red and a drop of blue. Maybe try to get some violet. You got it, Pooh Berry Blue, or excuse me, Pooh Berry Bear. All right. All right, here we go. Here's my drop of blue. Here's my drop of red. Here's my drop of detergent. Boop, and it goes. So what you're looking at is a phenomena known as viscous fingers. It occurs when a less viscous fluid, which is the dye that I'm using, penetrates a more viscous fluid, which is the glue. This is actually looking like black. I see a little bit of blue over there, but this actually looks black. I'm loving it. I'm growing a replacement here for Jake. Love it, Roger. Come on, Roger. Roger's winning the comments right now. Oh, man. That's really beautiful. So what you're seeing, those protrusions you see there, those are called viscous fingers, and they actually are fractals. Maybe try to drop two right next to each other and watch them compete when the soap hits each one. You got it. Let's try that. All right, let me back it off so we can see it over here. They do look like trees. Trees do display fractal-like patterns. A fractal is a geometric structure that has fractional dimension. So, like a line is 1 dimension, a square is 2 dimensions, a cube is 3 dimensions. A fractal has fractional dimensions. So, I've used some fractal dimension software analyzers, and I've measured the fractal dimension of these, and they come out somewhere between 1.68 for the dimension and 1.72. So I'm confident that if they're not exactly fractals, they at least show fractal-like behavior. Thank you there, James. Sorry there, Akuma. I don't mean to trap your ADHD brain. Let's do, let's see. I'm thinking we're going to go, we already got a red and yellow. Let's try a, I don't know what a Q book is. I apologize. I don't know what that means. Oh, do I have a book on this? So, okay, I'll tell you again what a fractal is here in a second. Y'all going to have to put your mature hats on here, okay? If you want to understand this further, you want to Google the phrase viscous fingering. That is what this effect is called, okay? So, put your mature hats on, everybody. Here we go. Drops of detergent. Let's see what goes on here. Yeah, these, I was talking to a neuroscientist prof at the university where I teach, and he says that this pattern displays similarities to neurons. So here we go. We got a red and a blue. Thank you there, Carachus. Thank you there, Adam. It is fun. It's beautiful. And what's crazy, it's so simple. Like you can grow your own fractals in your kitchen or in your garage or your basement or wherever. They're about to hold hands. I love it. I love it. Yeah. What's going to happen? Yes, IAH, it is just food dye in Elmer's glue. And then what you do is you add a drop of detergent in the center of the dye drop. It looks like they kind of stop, but man, look at look at the orange one, folks. Look at that orange one. So beautiful. It's like fire. And this one is like the dark of night with just wisps of blue over here on the left side and wisps of like brown almost on the right side. Very pretty. I wish I could figure out how to trap this with the real fine structure that the fractals have. Unfortunately, when I leave these to dry overnight, I find that the patterns bleed and spread. Adam, I have tried to get them to meet, and doggone it, as hard as I try, I do that at the end, Teresa. I flip the camera around, I talk to folks when the live's almost done. Yes, Pooh Berry Bear, I've actually put bread on there, and you can transfer the pattern to the bread. So I'm imagining it would work with paper. So a fractal, IAH, what a fractal is A fractal is a geometric object that has a fractional dimension. So a line has one dimension, a square has two dimensions. These objects have a dimension that's halfway between a line and a square. It's actually closer to a square. It has, if you measure the fractal dimension of these, it comes out to be 1.72. And that is, that's a good idea there, JJ. Oh, an angelfish. Come on now. God, that's really cool. The red one looks like an angelfish. I love it. So yeah, and a fractal dimension of 1.68 to 1.72 is indicative of viscous fingers. Yeah. These are my favorite. It's just so much fun. 3 colors at once, says Khaled. Gretchen says all the colors. Sure, we'll give it a shot. Why not? You want to do it in, let me know if you want to do honey, if you want to do clear glue, or if you want to do white glue with a bunch of colors all in one drop. Let me see it in the chat. What do you want to see? That dark one is pretty. It's like, oh, I don't know. It's a little ominous, isn't it? Really ominous. Let me know. What do you want? White glue, says Kevin. Clear, says Khaled. Blue and white glue, says PJ. I got 2 votes for white and 1 for clear. We're going to go a little bit longer. Thank you there, Adam. Appreciate the subscribe. You know what? I got to be honest with you, Adam. I was feeling a little down today, this evening. And I thought, you know what? I'm just going to do it live. And it's helping. Let me just put it that way. Thank you there, Adam. All right, we're getting most votes for white, so that's what we're doing. So let me put this aside. Let's get a fresh plate. Let's put in the white glue. Here we go. A little white glue. Thank you there, Gretchen. I'm loving some science too. It's the most, to me, it's intensely interesting. Freezing, what an interesting idea. I need to try that, Gemini. Like I need to take it and stick it in. I have access to liquid nitrogen. So while it's still in sort of that feathery, sharp fractal pattern, I wonder if I could just dip it in some liquid nitrogen. Come on, man. I'm going to forget, though. I'm so absent-minded. I forget crap. All right, here we go. So folks wanted to see a whole bunch of different colors. I'm just trying to spread it out a little bit here, okay? Thank you there, BF. So I've got the white glue in a plate. All right. And now we're going to do, I got to move, I guess I don't have to move that quickly with the white glue. A drop of green. Boop. A drop of yellow. Thanks, Adam. Appreciate it. Drop of yellow. Drop of red. Drop of blue. We're doing it, Akuma. We are doing all the colors. All right, and then the drop of detergent. So that's all the colors I got. And it goes, see what happens. I'm going to add a little extra just for the heck of it. All right, folks, this is what you wanted. It's going to look like the color wheel. I think it's just going to be black because it's all going to mix together would be my guess. But maybe we'll get some flecks of color. I like how these little like puddles of the white form. I see that a lot. I wonder what's going on there. Wonder what something like rubbing alcohol would do. We can do that. Let's do it over here on the side. So while this one's running, I'm going to put it here, and I'll quickly do a drop of yellow, and then I'll chase it with some rubbing alcohol. I'll do that real quickly. I don't think I tried this. Here, let's do blue. What if you try making a perimeter with the dyes and put soap in the middle? Interesting. Gemini says the rubbing alcohol will only dry out the glue and nothing interesting is going to happen. Well, let's just see. I don't know. You're probably right. Cheeseball, what's going on is I am adding a drop of dye to some white glue, and then I add detergent. And when that happens, the dye spreads out in these patterns known as viscous fingers. All right, here we go. Let's add our drop of alcohol. Holy cow, that happened quick. That's different. That's different than what I saw in the, let's really chase it here. That's different than what I saw in the clear glue for sure. I think it's happening too fast to form. It looks like I don't know. Is there something happening over there on the edges? Maybe. Yeah, there's some fingering going on. Yeah, you see that? Some fingers being formed on the outskirts. Come on, there we go. The alcohol worked. Great suggestion. There's so many ideas, y'all. I wish I had something to write all this down. Secret channel, where do I get my stuff at? I'm just curious, bud. I see stuff and I just start fiddling around, you know? It does look like an eyeball a little bit, doesn't it? Like a blue eyeball. That was cool. Come on, I love it. I love it when the people in the chat have me do something and I think it's going to be a dud and I am wrong. I love being wrong. Because when you're wrong, that's when you learn new crap. When you're wrong, you can figure out how to be better. Very cool. Of course, that's gorgeous too. Man, it looks like it's like ominous art, isn't it? What the heck? I mean, that's what's crazy about that is it's like artistic. I can never make something like that. And yet I did. You know what I'm saying? I mean, I didn't. Nature made it. I just set it up. I didn't set it up. We set it up. So beautiful. Sauce key. I did not add soap to this one. I added a drop of blue dye. So it's blue dye on white glue. And then I added a drop of 70% isopropyl alcohol. Yeah, we gotta try some more of these. Let's do alcohol again. Gosh, that's just beautiful. So happy you all encouraged me to try that. Okay, here we go. There we go. Drop of, it's like a neon pink. It's red, basically. Here's my alcohol. I'm gonna give it a bunch of drops here. 5 drops. See what happens. It's like exploding. It's like exploding into the universe. Oh, nice. Put some alcohol in the middle, Denise. I could try that. I doubt it, Gemini. Try 1 drop of detergent. You know, you all have a lot of very interesting ideas. And what's cool is you can try it on your own, right? I mean, you all can buy white glue. You all can buy dye. You all can buy alcohol and all sorts of stuff. You're right. I haven't tried the peroxide, Gemini. What about honey and clear glue together? So many cool ideas. So many cool ideas. I want to try this one. I'm going to mess up the pattern. I apologize. But look at this, though. Gosh, it's really cool. I'm going to try adding some alcohol to the middle of our monster here. I don't know what else to call this. But we're going to add some alcohol to the middle of this and let's just see what happens. See if something cool happens. I doubt it. I think I'm just going to ruin everything. I do not, Commando. I don't have any acetone. I'm not in the lab right now. I'm in my basement. I can do these experiments in my basement. So I'm adding a bunch of alcohol here. And you can see it spread out. I don't think it's doing much. I don't think it, well, you can see the alcohol front over here, right? You can see it sort of spreading through here. You can see it spreading up here. You can see it starting to make things bleed. Oh, I should have, Akuma. I should have took a screenshot. It's all right. We can make another one. Oh, it's cool. Come on, Jungle. We try to keep it Keep it clean in here. Sometimes there's kids hanging around. Oh my goodness. Nice, Adam. Yeah, maybe I did too much alcohol. All right, I think we're gonna go to flipping the screen around. Gonna end the live here. I'm gonna talk to you, so beware. You're gonna see my ugly mug, and I'm just gonna chat for a little bit before calling it a night. So that just giving you a fair warning. It's time to see my face instead of see the beauty of the. Thank you there, Joey. The beauty of the science. Okay. So long, cheese ball. Yeah, fair warning. Get out of here if you don't want to hear me yap on. Got my readers on so I can tell what's going on. Thank you there, James. I think you're right, Khaled. Fractals, rivers and mountains. Karashish. Thank you there, Akuma. Ooh, Seth, I don't know. Who do you think? Thanks there, PJ. Awesome. Yeah, my wife got these for me. She got my reading glasses for me. I agree, the chemical. Yeah. Let me know if you try it. Pop it in the comments. I have no idea what that means, Mariah, so I'm not saying it. I'm too old. I'm not up with all the slang of the day. I don't make tie-dyes, Caricious. Tie-dyes would be cool. Thank you, Adam. Yeah, I hope to see you around. Thank you there, Cheeseball. I appreciate that. Thanks for hanging out. You guys are awesome. Show my feet. Oh, what started my inspiration for science? Gemini. I've always been like, I love to learn. And, when I was in college, I could have been anything. I loved it all. English, science, art, the whole 9 yards, man. And I had this chemistry class, and I had a professor who did, he did experiments in class. And man, I was blown away. I was just mesmerized at the, got it. I got all I need. I got my wife. That's all I need. Yeah, I was just blown away by just the beauty of it, and not only the beauty of the science experiment, but being able to understand it. That was really cool. Yeah, I do other experiments lives, James. Yeah, I do. Yeah, so I changed my major to chemistry and, started teaching science. Good stuff. Yeah, and anybody, hey, hello, James. Hello, James from Russia. Drop in the chat some, what you do, what you like, some of those things. Thank you there, Cheeseball. I appreciate that. Hello there, Juanita. Potato battery would be funny. Akuma, I am working on a battery video where I use some really simple things. PJ, yes. PJ, there is some literature on doing these experiments with acrylic paint. I've not tried it. I say go for it. That's correct, Sosky. Sorry if I'm not saying your name right. Sauski, maybe. That's right, I'm a grandfather. Yeah, I'm a teacher of chemistry. Hello there, Mr. Goofy. All right, Caricious. Build a computer powered by fruits. Thanks there, Gemini. Hello, Skylar. Sosky, thank you. Appreciate it. Someone's a music major. Music and science are similar. They sure are. Sure are. Hello, VR guy. No, James, never have. Sure, I'll sing you happy birthday, Bear Killer. Happy birthday to you. Happy birthday to you. Happy birthday, Bear Killer. Happy birthday to you. What's my favorite chemistry fact? I think it's the fact that hydrogen atoms, of which 90% of the universe is made of, those were made within a very short period of time after the Big Bang. Thanks, PJ. Cheeseball, I usually do streams on the weekend. It's usually Friday evening. It's Friday evening for me here. And then sometimes I'll do a couple more, like I might do multiple ones during the weekend. No, I haven't. I have not, Bear Killer. James, I loved Breaking Bad. Very cool show. It was hard to watch, parts of it, but thank you there, Skylar. But yeah, I enjoyed it. We certainly do contain hydrogen. Have a good day, VR. PJ, did you enjoy that? You enjoy being a music therapist? Thanks, James. I am indeed, Squash. That's an interesting chemistry fact. You know, I don't hunt bear. I have, but I don't anymore. See you later, Cheese. So, you know, people say we're carbon-based life forms, and of course that's true. I mean, we are made of molecules that are primarily carbon. However, in terms of the number of atoms that make us up, human beings, we are made of a greater number of hydrogen atoms than any other type of atom. So in a sense, I mean, it is true that like carbon chemistry, of which we're made of, would be impossible without hydrogen atoms. So, you know, hydrogen is as important, if not more important than carbon, because you can't make carbon atoms without hydrogen atoms. You know, hydrogen atoms need to fuse in the core of stars to make helium, and then helium can fuse in the core of stars to make beryllium and larger atoms. And so the basis of all the atoms on the periodic table, including carbon, of which we're made, is starting with hydrogen. That is the key to making all the other atoms. I've not, Skylar. Oh, that's nice, PJ. I enjoy the fact that subatomic particles aren't the smallest thing in the universe anymore. Indeed. Indeed, indeed. Let's hear it, Adam. Can I put metal in the microwave? Sure you can if you want to. I wouldn't recommend it, but you can. I have not made a laser pointer microscope. That sounds interesting, Akuma. Have you? Yeah, Sosky, I might do that. What's my life goal, my purpose? It's to do good for myself and others as best as I can. Adam, I'm not a synthetic chemist. Name a car for edit. I apologize. I don't understand what you're saying there. All right, Sosky. Thanks there, Squash. How about you? Oh, homemade microscope. Cool. What's my main area of chemistry? Chemical. I'm a physical chemist. How about you? I am indeed a scientist, yes. Thanks, Gemini. Thanks for hanging out. All right, folks. It's time for me to head out. Thanks for hanging out this evening. I enjoyed it. It was fun checking out some of the beautiful things that you can see when you do some science experiments. Absolutely beautiful stuff. Pay attention to the world around you. There's always beauty around you if you just take the time to pay attention. Thanks for seeing some of that beauty with me here tonight, and we're going to see you next time. All right, folks. Have a great time doing whatever you're doing. So long. Nice. So long, folks. See you, show fit for you. So long.